Okay, so I'm going to do two things. One, I'm going to model addition of fractions with unlike denominators, and I'm going to show you also, excuse me, the strategy on how we've been solving these. So before I start, I'm going to bring out a whole number here just for scale so we can see what a whole number looks like. And then we're going to bring out, let's do 4/5. So 1, 2, let's put them under here. 1, 2, 3, 4. So this is the first part of our fraction addition problem. So if I have 4/5 here, so I have 4/5, and I'm going to be adding one of these other fraction tiles on there. So it will be addition. So I'm going to put an addition symbol here, and I'm going to add. Let's do 2/4. Oops, that's not working. Let's turn that off. Pointer. So we're going to add 2/4 to that. 1, 2. 2/4. So what we can see here is that I've already gone past the whole number, plus 2/4. So I can see that my sum of 4/5 plus 2/4 is going to be greater than a whole, because it's greater than this whole number up here. I'm going to show you the strategy that we've been doing to solve these fractions with unlike denominators. So the first step we do is we stack them on top of each other. So I have 4/5 plus 2/4, and this is what we've been doing in class. The next thing I'm going to do is I usually tell them to circle the denominators, but that's not necessary. I just wanted to make a point that these are the numbers we're trying to make the same, because we cannot add denominators that are different. They have to be the same. So we're going to do what's called finding the common denominator. And this is a strategy that I teach in class. It's pretty easy. It just involves skip counting. It can be done with multiplication as well, but I find this overall probably the simplest to follow for most students. So I start with the lower of the denominators, which is the 4, and I skip count by 4s, and I usually go at least 5 times deep. So 4 times 5 is what I'll end up with. So 4 times 1 is 4, and if I'm skip counting by 4s, then it's going to be 8, because 4 times 2 is 8, and then 12, and then 16, and then I'll end with 20. So that's 4 times 5. So I've skip counted from 4 to 20 by 4s. And then I have to skip count by the top. Now the top numerator tells me what to skip count by, which is 2. So 2, 4, 6, 8, 10. So I've done with the bottom. Now what I'm going to do on the top, since it's the bigger number out of the two numerators is 5, I'm going to skip count, and hopefully I can match one of these. Hopefully I can match one of these denominators with what I'm skip counting by for 5. And yeah, I can see it, but I'd rather show it to you. So 5, skip counting by 5, 10, 15, 20. And I'm going to stop there because now I've matched my 20 denominator with my 20 denominator down here. Now I skip count by the numerator, right? Because I have to do whatever I do to the bottom, I have to do to the top. So 4, 8, 12, 16. So now I have two fractions that have the same denominator, 16 over 20 and 10 over 20. I don't add my denominators, they stay the same. So when I'm adding and subtracting fractions, the denominators, once I match them, once I find the common denominator, I leave them, I don't touch them, it's 20. All I'm doing now is adding the numerators, 10 plus 16. So 10 plus 16 is 26. So I have a improper fraction here, improper fraction. And I have to simplify that, and I'll show you how to do that in the next video. I'll show you how we do this, right? And we can see here, if we look at our model, we can see what kind of an idea of how we're going to have a whole number in there, right? Okay, so in the next video, I'll show you how to simplify an improper fraction. Thank you.